next we're going to talk about order of operations. So the order of operations is necessary in order for us to simplify equations and solve expressions properly. So the order of operations is PEMDAS, right? That's an acronym. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. If you want to use a mnemonic, that's when you take the first letter of each acronym, right, and assign a word. If you please excuse my dear Aunt Sally. One thing I want to say, and something the internet gets a little confused about, because you've seen people argue about what the correct answer is, be it on like Twitter or Facebook. I don't know why they need to argue about math, but here's a clue. So it's parentheses and then it's exponents, but multiplication and division and addition and subtraction should really occur at the same time. So it should kind of be written like this, but that's not an easy way to remember things. So just remember that multiplication, division, and addition and subtraction are interchangeable. You just want to work from right to left. Right to left. Let's also remember that parentheses includes absolute value bars, brackets, things like that. So we're going to do a lot of examples, and what we want to do first is simplify our parentheses, simplify exponents, perform all multiplication and division from left to right, and then maybe last time I said right to left, but I mean left to right because that's how we read. And we need to perform all addition and subtraction from left to right as well. So 4 plus 3 times 7, the first thing I'm going to do is multiply. So that gives me 4 plus 21. 4 plus 21 is 25. You can see how that's different than here if I did 4 plus 3 first. It's in parentheses. That gives me 7 times 7, so 49. Parentheses make a big difference. Now I've got 18 divided by 9 times 2. I'm going to work from right to left. Sorry, left to right. Geez, I'm directionally challenged. Here's left, here's right. 18 divided by 9 is 2. 2 times 2 is 4. 18 times 9 is a big number. It's 162. 162 divided by 2 is going to be 81. So we worked from left to right. Next, I got 6 divided by 3 plus 2 cubed times 5. So parentheses, there are none. Exponents, there is one. So I've got 6 divided by 3 plus 8 times 5. I'm going to work division and multiplication from right to left. 6 divided by 3 is 2, plus 8 times 5 is 40. The answer is 42. It's the meaning of life. If you don't get that reference, Google it. I have, for problem 2, I've got an exponent in my numerator. So that gives me 4 plus 9 over 6 minus 5 times 3. When working with fractions, I want to simplify my numerator and simplify my denominator before I do the final division represented by this bar. So that gives me 13 divided by 6 minus 15, that's negative 9. I guess that's simplified, right? Because 13 is prime and 9 breaks into a 3 and a 3. This next problem is a little more complicated. I want to simplify my numerator and simplify my denominator. So I have negative 3 cubed. Remember that if I took, why did it get so big all of a sudden? There we go. If I took negative 3 times itself 3 times, that'd be 2 negatives, which make a positive, and another negative, so I'd have negative 27. So I've got the negative of negative 27, but instead of plus a negative 5, I'm just going to write minus 5. Over 2, this must be a typo, 2 minus 5 times 3, so that's 2 minus 15. So I've got negative 13 in my denominator. Now I need to distribute this negative because this is really like multiplication by negative 1. So I've got 27 minus 5, which is 22 divided by negative 13. And I'm going to leave this as a fraction. Here are some more PEMDAS problems. What is happening there? I will fix that in the PowerPoint that we post. Friendly reminder that absolute values act like grouping symbols. You want to simplify inside the absolute value first before working outward. So the absolute value of 27 minus 16, that's the absolute value of 11, which is 11. If I have 9, the absolute value of negative 7, the absolute value of negative 7 is 7. So 9 times 7 is 63. I'm going to take the absolute value of 8 minus 6, so that's the absolute value of 2 minus the absolute value of 12. Gosh, that gives me 2 minus 12, which is negative 10. I'm going to go down here and do one more little complicated example. I've got 9 minus the absolute value of 8 minus 4 times 7 minus 5. So I've got 8 minus 4. I want to do this parenthesis first. 7 minus 5 is 2. So I have 9 minus the absolute value of 8 minus 8. Well, the absolute value of 0 is 0, so I just have 9 as my final answer. When we're working with mathematical expressions and equations, I'd like you to keep in mind that a constant is a fixed unchanging number, right? So something like 1, a fraction, a decimal, negative 13, an integer. An algebraic expression is a collection of constants, variables, operation symbols, and or grouping symbols. So I've got some constant. If it's in front of a variable, we tend to call it a coefficient. Okay? And it's called an expression because it's a collection of terms, but it doesn't have an equal sign. When we're simplifying algebraic expressions, we need to combine all possible like terms. Okay, so that's going to be terms with the same variable. For example, here I have negative 2m plus 5m. We'll rewrite this as plus, right? Plus 6m plus 8. So negative 2 plus 5 would give me 3m, plus 6m is 9m. 3 plus 8 is 11. Here we'd want to go ahead and distribute. 3x times 5 is 15x, times y is 15xy. And last but certainly not least, I'm going to distribute this 4. I get 12x minus 20 minus 8x plus 7. I can't simplify within these parentheses, so I can rewrite it. 12x minus 8x is 4x. Negative 20 plus 7 is negative 13. So that's this expression fully simplified.